The technical term? Are you guys making inappropriate remarks?
No.
Yes, you are.
No, it's not.
No. All right. There we go. What do you suppose we're going to do with this once we get all the error bars on there? Are we going to do a best fit line through it, the points? We're going to do a best fit line. Piss switch. I got to quit cussing. This is like on YouTube. Although technically piss switch is not actually a cuss word. I know that's, and she's right. Your mom is right. So I'm just going to use the F-bomb. Okay. Here you go. All right. Now, let's pause a moment because I know that you guys could, and we'll probably have to because we'll be like a little bit time limited. But I know you guys could find the slope of that line, couldn't you? No. Right? What does the slope of that line mean? I'll let you think about that. What's the formula for the energy? What is the formula for the energy of ejected photons in the photoelectric effect? In terms of work function and Planck's constant, et cetera, what is it? Well, I know HF equals work function plus kinetic energy, right? Isn't that right? Isn't that right? This is the kinetic energy, this way, yes? Isn't that right? So the kinetic energy is equal to, what is it? It's the photon energy minus the work function, correct? Is that right? Is that right? It's the photon energy minus the work function, yes? So let's look at that formula, okay? Y equals HF, F being the x-axis, right? Minus W. So the slope of this is what? Planck's constant. This might be how you might determine Planck's constant, right? So the slope is what you multiply by the frequency to get the kinetic energy, right? But you have to subtract the work function. So what is the y-intercept of this thing? What is the y-intercept of this graph? Negative the work function? Yeah. Listen, please, guys. Can I have everybody's attention? Right, so remember that the energy of these photoelectrons is the photon energy minus the work function, yes? Yes? Okay, the work function is just a constant. That's your y-intercept. Doesn't this have a negative y-intercept? That's why it does. We're taking away the work function, right? So the energy of these photons right here, whatever that is, right, is equal to what? The minimum energy photon that can take an electron off of there has an energy just equal to what? There are two possible things you could say here, the work function or Planck's constant. And Planck's constant is not the right thing. Yeah, there we go. So what does that mean, right? The work function is the energy needed to take it off the surface, right? So if the photon has enough energy to take it off the surface, and that's it, right? Then it's got an energy just equal to the work function, right? Yeah? Okay? So that's what's going on, is that if you give it even a little more energy, remember this axis here really is energy, isn't it? Photon energy increases this way. If you give it even a little more energy, then it actually ejects the electron with extra energy, yes? Okay, it's ejecting the electron with extra energy. This one took 0.4 volts to stop it. It was going so fast. This one took 0.7 volts to stop. This one took 0.9 volts. It went all the way through, decelerating the whole way before you stopped it, right? So this is increasing energy. the zero, the cutoff there, the cutoff frequency where you don't eject them at all, this energy of this guy, right? The photons have just the work function, right? Okay, so you can figure this, the work function is just HF naught, this is F naught, right? Whatever this frequency here is F naught. Yes, it is. Okay. So what we're going to do, and this is exciting and it's coming soon, right, is that obviously we got to, interpolate that and figure out the work function from this. This is what they'll ask you on the test, right? And then we've also got to find the slope, and that's also super duper exciting, right? We've got to find the slope of this line, and the slope of the line is going to be Planck's constant, right? And then, of course, Planck's constant will have an exciting maximum value and an exciting minimum value, between which, the actual Planck's constant will lie. Isn't that exciting? Can you hold on to yourself until then?
No.
I don't know.